This is video 4.1.3 on Desmos. Alright, so sometimes you might be at home and you're trying to do some problems and maybe you don't have a graphing calculator at home. So I wanted to teach you how to use Desmos. Also, there might be situations in the classroom where you're not going to have access to the graphing calculator. They're kind of expensive and I really don't have enough to go around to all of the students. So I want to teach you how to use Desmos as well. Desmos you can get from any internet connection. And it's a pretty good graphing calculator. So here we go. So I'm going to start by going to Google, and I'm going to Google Desmos. Alright, so there it is right up top, Desmos Beautiful Free Math. And I'm going to click on Start Graphing. Takes a minute to load. Okay, so right here on the left is you can type whatever it is you want to graph there. All right. Let's see. What is my equation again? Move this over a little bit. Okay. So my equation is y equals negative 3x squared plus 5. I'm going to type that here. Oops. Negative 3x. The squared button would be here on the screen. What was the equation again? I forgot it already. Plus 5. Alright. So there's my graph. Alright. I can zoom out. If I want to see more of it, I can zoom in. If I want to see closer, I can drag the screen to see different parts. Okay? Alright, there we go. That's my standard viewing window again. So, I need to find the vertex. Alright? So again, the vertex is at negative b over 2a. That's the x-coordinate of the vertex. Typing bad here. There it is. Okay. So, what have I got here? In this problem, I have a equals negative 3. I'm going to switch over and write it instead of putting it on here. Okay. Trying to do things too fancy. Alright, so I have y equals ax squared plus bx plus c. Okay, for this problem a equals negative 3. Okay, b. Now there is no x term. There is no term that has just an x in it to the power of 1. So therefore, b equals 0. The constant term, that's c, the one that has no x, is 5. This is going to be concave down because a is negative. Let's find the x-coordinate of the vertex. So I have x equals negative 0 over 2 times negative 3, x equals negative b over 2a. So I have 0. 0 divided by anything is 0. So the x-coordinate of the vertex is 0. I'm going back to the graphing calculator. Okay. So I'm going to, over here in my table, I'm going to add, all right, and then it gives me some choices. So I'm hitting the plus thing, and then I'm going to say, I'm going to put a table in right now. Okay, I see what the graph looks like, but just on the, on the graphing calculator, I want to use a table. Now this table is different than the one on the graphing calculator. What you want to do is you want to go up to the very tippy top of that table and change these to x, and then instead of y1, erase that, and put the expression for y. So I'm going to put negative 3x squared plus 5. Okay? So that's going to be everything that's on the right-hand column. All right? Unlike with the graphing calculator, it doesn't just give you a list of points. You have to tell it what x you want. All right? Now, what did I figure out the x-coordinate of the vertex was? It is 0. Okay? So how about if I place a 0 over here in my table in the x column? Oh, it calculates for me 0, 5. And look, it put a dot at that point. So I'm visually confirming, yes, that is the vertex. Okay, that's the highest point on the graph. So I've got 0, 5. Let me go back to my paper, and I'm going to write down 5. Okay, I'm going to plot 0, 5, and then the axis of symmetry is the dotted vertical line that goes through that point. So it's the y-axis is my axis of symmetry for this problem. All right, so now I'm going to go back to my table. Okay, and I want to plug in another x. So I want to pick a number close to 0. Let's pick 1. All right, so it says if I plug in an x equals 1, y equals 2. All right, now let's see, that point is right here. So that's 1 away from the axis of symmetry. What's 1 away on the other side? Well, that would be negative 1, so let's put a negative 1 over here. Oh, good, the y-coordinates are the same, okay? They have to be in order to be reflections across the axis of symmetry. All right, so I'm going back to my paper, and I'm putting in, what am I putting in? 1, 2, and negative 1, 2. Okay, let's plot those points. So I have 1, 2, and negative 1, 2. All right, and then one more or two more points. Another one close to 0. 0 is the vertex. So how about if I put in now 2? I already picked 1. Let's pick 2. Oh, you know what? Nah, that's not going to work. I'm sorry. I'm going back and forth. So I have 2, negative 7. All right. Let's drag the graph up a little bit so I can see it. There it is, 2, negative 7. All right, so that is 2 away from the axis of symmetry. If I go 2 more on the other side of the axis of symmetry, I have negative 2. So let's get that one too. So I'm going to get negative 2 and make sure that also gives me a negative 7. Let's put that on the paper. 2, negative 7 and negative 2, negative 7. All right, let's plot those. We have 2, negative 7. That's right there. And then negative 2, negative 7. All right, and then I'm going to graph it. It's very obvious on this one that this is real skinny. Okay? If you were to compare that to the parent graph is wider. All right? So This is concave down, okay? It's opening down. It's a sad face because A is negative. The absolute value of A is 3. That's greater than 1. So that means this is a skinny parabola. Oops, you're not seeing what I'm writing. Hold on. There you go. So the absolute value of A is 3. 3 is greater than 1. This is a skinny parabola. Alright, that video is too long too, so that's it for that.